Connecting. Okay, hi, we're here. Let's wait for 1 minute to ensure everyone has successfully joined the webinar. We have many attendees joining right now. Thank you. I believe we are now more than ready to start. Hello, everyone, and thank you for joining our new Kumo AI webinar. I'm Kitty Jovanovska, and I will be your host today. The topic of today's webinar is Build Highly Accurate Machine Learning Models Faster with AI. Our speaker today is Hema Rakhavan, co-founder and VP of Engineering at Kumo AI. Hello, Hema. How are you today, and can you hear me?
Absolutely. And thank you so much, Katie, for the warm introduction.
Thank you so much, Hema. So in this 30-minute session, Hema will explore how data scientists can leverage AI to accelerate machine learning model development. Please note that you can ask questions through our Q&A feature. And at the end of this webinar, we will dedicate 5 to 10 minutes to address the most common question. And also, it is important to mention that today's presentation will be recorded and shared with you. Thank you once again for joining us. Hema, thank you for being our speaker today. And I believe that we are all excited to learn from you. And also, I think that we are ready to begin. So, Hema, over to you.
Thank you, Katie. And, I want to start with what gives me great joy in, the Kumo product, as well as what made us form this company, right? I've spent over a decade in, the ML, industry as an organization leader, and many years as an IC before that. And what really draws me to this field is the ability to have business impact, whether it is building ad CTR models, or it is building recommender systems, or search, or driving growth for your business. You can always put a model out there, and you can quantify your direct business impact. So it was great for me as an IC. It was great for me as organization leader. But it was one of the observations that for my teams, as well as for individual contributors, the data scientist today is pulled in many different directions. There are few data scientists relative to the size of an organization, and often you're servicing many different teams. You might have someone who's, a product engineering team asking you to optimize your app notifications, or a marketing team asking you for next best actions. And now, especially with the AI boom, every product or vertical or line of business wants AI in their product. So for a data scientist today, the world is still, pretty painful, because and many of you say things like, AI is clunky and needy. And when you double click on that, it's just that you have to write a lot of workflows to get data into AI, to be ready for AI. And it's very resource intensive, requires you to write a lot of SQL workflows. And sometimes it might require you to even, go modify front end and back end code to make the entire application work end to end. All of this makes doing AI also very delicate and brittle, because you're touching so many parts of a system, and thereby a single bug can actually completely, break the entire product. And then you spend hours debugging. And this can be very frustrating for a data scientist. So that's to make AI easy, or less painful. We actually decided to build Kumo. And in this talk, you will actually see how the Kumo product, uses deep learning techniques to actually make AI so much more easier. So let's look a little bit more at where the pain point is, right? So if you are in an organization, you probably have a lot of data in tables. And, tables that may come from Salesforce, that may be in your data warehouse, ETL'd by your data warehouse engineers, having your click events, tracking events, page view events, and so on. You may have product catalogs, you may have image files, you may have all of these resources, and you're trying to bring them all together. And most typically, you're trying to do that in the first part of your project to create a training table. And training table creation is not the end of the story there, because you iterate on your training table, and then eventually when you find a great model, you need to productionize it. And that brings, another set of pain points. I'll give you an example of a feature that is particularly painful, right? So if you start thinking of features that are time-based, let's say CTR-based features, right? Click-through rate-like features, you have to go back in time and you have to figure out what was the, click-through rate of a user to an item or an ad in a particular period of time. And that's typically called your training sample time. And then you have your label generation period, which you hold out and you look at forward-looking, what happened in the ecosystem to generate your labels, right? And creating all the SQL code that does this time travel is where the pain exists, and one of the pains that exists. And you'll see through this talk how we eliminate some of this pain through the use of neural networks in Kumo. Another big bit is there's been a lot of tools. There's been a proliferation of tools that says, we're making AI easy or helping you productionizing it. But most of these tools, don't bridge the gap between the data warehouses and where the tools reside. So many of the tools are directly built on, the public clouds, but then you don't have something that sits natively within your data warehouse. And that was another observation that we, made in the building of Kumo, which is that there's a lot of data sitting natively in your data warehouse, and then you don't have to move things in and out to be able to build AI. Why can't we just straight work in your data warehouse? So we are data warehouse native at Kumo. So overall at Kumo, we heard you. We heard the pain points. We've experienced the pain points, and that's what created the product. And if there's anything you want to take away from this talk, and without understanding the underlying technology, you should understand that the key observation here is that relational data, or data sitting in all of your tables, goes in and is naturally represented as a graph. Okay, so the core technology here is graph neural network, and Kumo's approach makes graph neural networks very easy to use on a data warehouse, and we can apply it to many different use cases and problems. So AI in Kumo, that is the graph neural network-based AI, creates the first level of the model, and you as a data scientist then can look at that first level of the model and start refining it, right? So that is the core idea, and I will go deeper and deeper as this talk unfolds. The core bit here is we want to eliminate the drudgery of feature engineering and training set creation. So, for example, if you have all of these, complex relationships in your data, it's all the structured data. Graph neural networks capture that. And oftentimes people ask us, how does this fit with large language models? Large language models are great at creating features for text and image data. So for example, if you have a product catalog or an image catalog, by all means, and you'll see this in the talk, is that you can use an LLM to encode that kind of data and combine it with your structured data into an integrated architecture which combines both GNNs and LLMs. With this efficiency, the ability to eliminate feature engineering, Kumo gives you answers in hours. So you're not spending months. Sometimes, engineers are spending 3 to 6 months building models. We give you more accurate, explainable predictions, and we're able to take you to production much faster. We'll give you a couple of examples before we go deeper. So this is an example from a food delivery service, and they use Kumo to predict what new restaurant will one order from today? So they send a notification for this. And this try something new or try a new restaurant notification is run as a batch prediction job. It takes just 4 hours in Kumo. And the company had a baseline model, which was, a classic XGBoost-like model, which gave and Kumo gave over 30% mean average precision improvement on this model. Online, they were able to get to A/B test within a matter of a month or two. And this was largely, work that they did to set up the A/B test environment and set up the notification copy and all of that. They got to an end-to-end system in a couple of months, and they were able to drive $100 million or over in sales in that short period of time. Another example is from an e-tail marketplace. And again, this is a problem which is, what unique item should I recommend to you? So here, Kumo creates personalized recommendations from millions of items. And in this case, the customer has all one-of-a-kind items. So it's entirely cold start. And Kumo does very well on this problem as well. We were able to beat the customer's production baseline by over 20% in offline, and the customer is productionizing that today. So why is Kumo so much accurate than classical methods? The power here is on the graph structure. So if you start thinking about how you do classic ML today, there are users, there are stores, there are orders, and you're doing a lot of feature engineering across all of these different tables. We construct a graph across all of these tables. Think of Kumo as a neural network that goes across your entire data warehouse. That's what Kumo is, across all of the cells, across all of the tables in your data warehouse. That power to capture the relationships automatically inside your graph neural network is what eliminates feature engineering in Kumo. The neural network is capturing all those features. It's the same revolution that happened in LLMs and in the field of transformers for text and images that we are bringing to the data warehouse. So that makes it very easy for us to answer questions like, will this person who looks like Will Wheaton order from this restaurant or this pizzeria in the next 7 days? Our typical out-of-the-box results come in the first 3 to 5 days, and we see anywhere between 15 to 30% improvement. And this we're able to repeat from one POV to the next POV. And this is the part that gives me great joy and always gives me goosebumps about both building Kumo and seeing it in customers' hands. So how does it work? One of the things I've mentioned here is that Kumo uses graph neural networks, and graph neural networks are intrinsically hard to use. Kumo has given you a very powerful abstraction called predictive query language, which is very SQL-like, that lets you specify these kind of business problems, like which customers will churn in the next 30 days to specify your ML problem. So this is what, we've replaced your tens, if not hundreds of SQL code with this 3-line SQL-like query. And think of it as SQL with a predict clause. And it generalizes well across so many use cases like, recommender systems, churn prediction, fraud, etc. And really the observation while building Kumo was that once you construct the graph, most ML problems can be reduced either to node prediction problems or link prediction problems. Once we had that observation, we were able to create this very simple but very rich abstraction called predictive SQL. And then once you have that first model, on the right-hand side, what you have here is a set of parameters that you can tune. And so you have control over your model. You can decide your data split strategy. You can decide how you want to sample. You can decide that you really want to know more about GNNs and tune the GNNs. By all means, go and tune, the number of neighbors that you have, the model architecture, and so on and so forth. And now coming back a little bit as to how we fit within that LLM architecture is we complement it, right? So I mentioned earlier that we capture time-based features and relational features really well. Vectors are a first-class citizen inside Kumo. So if you have columns that are text, like in this case, this is a tank top, and you might want to represent this as a narrow top with shoulder straps, or different semantic interpretations can be captured in these embedding vectors and brought into Kumo. And we support multiple open source and commercial LLMs that you can bring these features in. So bringing it all together, what Kumo gives you is a very rich predictive query language, which lets you automatically construct an input graph. We combine the dense self-attention that comes from LLMs with sparse self-attention from the graph neural network that captures the relational structure. And we give you a very powerful paradigm in which to specify ML problems. In addition to that, and you'll see this in the demo, is we give you explainability. So it allows you to build trust within your organization. We let you explore through graphs, the contribution scores, the variations of predictions, column analysis, etc., that you can talk to your business owners and explain why the Kumo model is doing well or not in certain cases. The typical way that people use Kumo predictions is to write the data back to their data warehouse, and then they plumb it back into a key value store for real-time serving. And in this way, people are able to plug in Kumo into model inference in apps or in notifications or email pipelines. Our architecture looks something like this, and you will find this on our public docs as well. We have several connectors for our SaaS product on many public data warehouses. At the back end, Kumo is a large-scale distributed system that allows you to scale graphs massively. So in fact, some of our biggest graphs can go to 50 billion nodes or more. We also allow for multiple deployment models. So we have our SaaS offering, which is a fully managed service, but we also allow you to push down compute completely into Snowflake through Snowpark Container Services. So if your organization is security sensitive and would prefer that your entire compute and data stay within your warehouse, SPCS is a great deployment model. We have a similar deployment, which is also safe and secure with Databricks. So at the end of this talk, we will give you means by which you can reach out to us for these different deployment models. And this is an architecture diagram that allows people to see how Kumo is used in production. This is an example for that churn prediction use case where you may bring in many data sources into your data lake. Kumo writes back into your predictions, and then you write further workflows to pull it into tools like Braze or Elasticsearch or your Google Ads campaign manager, for example. So this is our data scientist, and hopefully she's a lot happier with Kumo. She can service all her business partners, and she can do much more than that and have a lot of impact for her business. So the recap of Kumo is you get answers in hours, not months. Get more accurate, explainable predictions, and you get to production much faster. As I mentioned earlier, we have multiple deployment options, and here are some QR codes that allow you to contact us if you want to consider these different deployments. Up next, we will actually have a small demo of the product, and you can see how easy to use it is, and you will get a sense for the look and feel of the product.
Kumo is an AI solution that helps data scientists quickly and accurately get predictions from the data warehouse. Your data science teams are working to create models that predict user and customer behaviors to help you grow your revenue impacting KPIs like engagement, sales, and conversion rates. However, this process is extremely time consuming, usually taking months for a marginal improvement. Kumo is an intelligent approach that is designed to help data scientists quickly and accurately get immediately actionable predictions using AI. Today, we'll show you an example of personalized recommendations. Let's pretend we are a major retailer who wants to improve sales among college freshmen by offering a personalized advertisement to each shopper in their database. Kumo splits up this business objective into two questions. First is, who is a college freshman? We're using age as an approximate gauge for identifying college freshmen, and you can see here this simple query we've written to help us fill in the gaps for any users who do not have age filled in their profiles. Now that we know everyone's age, we can ask a question about that segment. What items will a college freshman buy? This is another simple statement in Kumo. Kumo is busy behind the scenes training a machine learning model that will be able to answer this question. The traditional data science process to do this takes around 6 months, but we're able to do it in just hours. Once the model is built, we can look at its accuracy and performance rating to see if we want to make any other changes before we make our predictions. We can even explore the success rate of each individual recommendation to see the results of our predictions. Here you can see that Kumo successfully predicted the purchases for this user. So how does Kumo know what products to recommend or how to predict someone's age? It's because we're using a graph structure behind the scenes. The graph structure helps us predict where links are likely to occur based on all of the connections found in the graph. Think about LinkedIn and how it recommends people it believes you know. Same idea. The graph structure is the foundation that our AI learns from. Once we're happy with our model, we can immediately take action on the answers to our business questions by exporting them to any data warehouse or storage for use downstream. Now the marketing team can pick up those predictions to make the flyer. Today we talked through a short example of how Kumo can help accelerate the ML development process for your data scientists so they can get accurate predictions in hours, not months.
Thank you all. With that, we will take questions.
Thank you so much, Hema, for sharing your knowledge on how data scientists can leverage AI to accelerate machine learning model development. And thank you to everyone who sent many questions through our Q&A feature. In the interest of the time, we have selected 3 questions to answer, and we will follow up with you individually regarding the remaining question we have received. So, Hema, the first question for you comes from Dominic, and it's as follows. How do you do embeddings? Also, how long does it take Kumo to learn and prepare models?
So a great question, Dominic. So Kumo's predictive query language lets you specify whether you want the outputs as exact predictions or you want embeddings. So we have customers who use both modalities. And for your second question on time, it really depends on your data set size. So for a public data set like H&M, which we often benchmark ourselves to, it can be, the models can take anywhere between an hour to 2 hours, depending on the kind of prediction problem you specify. But then we have larger customers with 50 billion node graphs that take a little longer. It also depends on the machine sizes. but usually within, 4 to 6 hours, I would say. Thank you.
Great, thank you. The second question is received from Akira, and she is asking, with regards to model explainability, are 3 plots indicating model performance stability in addition to contribution? Many model explanations are unstable. Hema?
I think, again, very good question. So I want to say that oftentimes model explanations are not stable when the models themselves are not stable. Kumo gives you, during the training process itself, you can actually see the model performance over different iterations. So you would know how much variance there is over iteration. So that's one way to get a sense for stability. The other is in the model planner, you can control, the number of epochs and the other parameters that give you greater control on stability. So hope that answers the question on stability. Stability is a hard problem, but that's where the data science, the knowledge, the ability to play around with different graphs and manipulate the graphs comes in. We want to make that easy. And as you play with that, you will get more and more stable models.
Thank you, Hema. And the last question is from Rias, and is the following. Does the Kumo allow download of the model output charts for governance?
Absolutely. So everything that Kumo emits in the UI, you can download and you can use it for governance purposes or review purposes that you need inside your organization.
Great, thank you, Hema. We are now at the end of our webinar. I would like to ask you if you have anything to add before we conclude.
I just want to, thank you all for being here and listening to the talk. It's been super exciting building Kumo. We really want you to try the product, sign up for a free trial, and we'd love to see you as a customer. Thank you.
Thank you, Hema, and thank you to everyone who joined this webinar. I hope that you gain valuable knowledge about how to build highly accurate machine learning model faster with AI. And please don't forget to follow us on social media to learn more about Kumo new functionalities, our upcoming events and achievements. And we're also available 24/7 to respond to all your questions. Thank you once again. Have a lovely day and bye.
Thank you.
Thank you.